Well, I know it's a lot, but this is the last part of this lesson, so hang in there. We're almost done, okay? We're going to kind of take from last video and create a different table here. I'll move this down so you don't see that part. Just trying to fill in the pattern here, okay? Where we've got 2 to the 5th. If we find its value, if we evaluate it, it's 32, right? 2 to the 4th, 16th. What would go here? 2 to the 6th. It's like taking this and multiplying it by 2 one more time, right? If we go this way, it's like we're dividing it by 2, right? Every time we lose an exponent, it's like we take half of that number, right? Every time we gain an exponent, we double that number, right? So it depends on the direction we're going, right? So if we're going this way to fill it in, we would say 5, 4, 3, 2, 1 factor of 2. And 1 factor 2, 1 less than what we have here. Divide this by 2. Anything to the first power is itself, right? Okay. Well, let's finish this going backwards here. 2 to the 0 power. Well, we just said anything to the 0 power is 1. And we can show that because we keep dividing by 2 here, don't we? 4 divided by 2 is 2. 2 divided by 2 is 1, right? If we go to the negative 1 power, again dropping down an exponent, we're reducing those factors like dividing by 2, 1 divided by 2. And if we go to 2 to the negative 2, losing a factor of 2 like dividing by 2 again. Dividing by 2, multiplying by the reciprocal of 1/2, half of 1/2, 1/4. Another loss of an exponent, 2 to the negative 3, taking half of what was here, half of 1/4. And if we go down to our last one in this row, 2 to the negative 4, half of 1/8, dividing when we go down like this, divide by 2, taking half of. I want you to see this kind of, you'll do this a lot next year, this, call it kind of this rainbow effect, right? Do you see that what was in the numerator is kind of now in the denominator? So another thing I want to kind of point out is that if we were to talk about the rule that we just mentioned about negative exponents are just really small, they're fractions, they're decimals. If we don't evaluate it, just express it as a power, this would be 1 over 2 to the positive first power, right? This is 1 over 2 squared, 2 to the positive 2. This is 1 over 2 to the third. This is 1 over 2 to the fourth. So these are equivalent, right? But this negative decimal means a small number. It's a fraction. 2 to the negative 4 is the same as 1 over 2 to the positive 4. So the thing about negative exponents is that they're considered unsimplified. We technically don't want to have negative exponents in a power or in an exponential expression. And so this is really useful to know, well, I can get rid of a negative exponent by just moving it to the denominator. This is considered to be in the numerator, right? All these have this invisible denominator of 1, right? Everything up here has a denominator of 1. This has a denominator of 1. Push this to the denominator and the exponent becomes positive. Really powerful, really useful. We're saying that we're not simplified if we have negative exponents. It's kind of like when we're reducing fractions. You have to get it all the way reduced. Same thing with powers. We have to simplify them all the way. Okay, I think we'll skip this one, but just a quick, okay, we can kind of tell this was hopefully because we've memorized these, right? I'm just going to show you really quick that pattern. Not going to take too much time, but 64, 1 over 64. Big number, much smaller number, right? So see that idea? Anything to the 0 power 1, anything to the first power itself, right? Again, this is also the same as 1 over 4 to the first, or 1 over 4 squared, or 1 over 4 cubed, right? All of these equivalent. Okay. Okay. Quick review on this too, that a to the 0 is 1. If we use that rule here when we are multiplying powers, if we were to add our exponents here, when we multiply with the same base, we add the exponents, we would get 2 to the 0, and that's 1. Same thing here. So just using a different property, to the 2 plus negative 2, that's 3 to the 0, or 1. Okay. All right, so what is it that we want to kind of walk away with here? Two things. Now, if we look at what we did in this top part, what can we conclude about negative exponents? Well, they represent fractions. Numbers less than 0. Because we could do it as a decimal, I suppose. Okay. The other thing that we want to kind of zone in on is negative exponents, because we say they're not simplified when they're negative. Well, you can make them positive. They become positive when they're in the denominator. And so we kind of say it's being moved there, but they're just equivalent. It just means the same thing. But basically, if you see a negative exponent, we just want to move it out of its position in the numerator to a denominator. So let's just do a couple small examples here. 6 to the negative 2. Well, if I'm going to simplify it, and expressions that are simplified don't have negative exponents, 6 to the negative 2 is the same as 1 over 6 to the positive 2. This is like that invisible one. It's a placeholder. Remember, negative exponents represent fractions. If they wanted me to evaluate it, it would be 1 over 36, right? Now if we came down and did this one, right? Well, to get rid of that negative exponent, it just represents a small number, right? It's 1 over negative 4. We need the parentheses to the positive 3. We need the parentheses, remember, when we're doing negative bases. Otherwise, it would be the opposite of 4 raised to that third power here. And we could, yeah, say 1 over a negative times a negative times a negative, negative 64. Okay. Now, it's really important that we don't overgeneralize this negative rule to just negative bases. It has to do with negative exponents only. Okay? All right. Take a minute. Maybe get up, pause this video, stand up, get a piece of paper. I'm going to have you write down a couple things. It's going to be pretty important for when you are doing your work for this next set of exercises or assignments, okay? So we want you to write down the rule for exponents of 1. And I've got 3 examples for us here, okay? X to the first power, 1 factor of x, x. 5 to the first power, 1 factor of 5, 5. And negative 2 to the first power, it's just negative 2. Anything to the first power is itself. And if you want to write that down in words, if that's helpful to you, do that. Anything to the first power is just itself. Second thing that we learned from this lesson, anything to the 0 power is 1. Anything to the 0 power is 1. Doesn't matter what it is, it's going to be 1. Now there's, we can't, again, overgeneralize this rule to everything, but you'll find out just kind of some sticking points to that in the lessons to come, okay, in the practice to come. And then the last thing is we learned about negative exponents. Negative exponents just means we've gotten smaller instead of bigger. When we think of powers, we tend to think of growing bigger and bigger and bigger, right? More exponents, bigger the number. Well, the smaller the exponent, the smaller the number. So this is the same as 1 over x to the positive 1. This would be the same as 1 over 5 to the positive 1. And this would be the same as 1 over negative 2 to the positive 1. Move that negative exponent to the denominator. Again, technically, all these have a denominator of 1 right now, right? And then when we move it, we have a placeholder of 1 in the numerator position. Now, something that we won't necessarily practice right away, but I want to put it out there for you so it doesn't like freak you out when it occurs, is that the opposite can be said true. That if we have a negative in the denominator, well, it stands to reason that I would move it to the numerator to make it positive. Negative exponent, if I switch its position in the fraction, it becomes positive. If I have a negative exponent, I just switch where it is. It's in the denominator, move it to the numerator, and now it's a positive exponent. So negative exponents work both ways. Wherever you see a negative exponent, if it's in the numerator, you move it to the denominator and it becomes positive. Or if it's already in the denominator, you move it to the numerator and it becomes positive. Okay. All right, we are going to practice this, and then we're going to start pulling some of the properties together, and that gets kind of tough, so you may want this in front of you. First thing you're going to do is take a real short, simple Schoology quiz on this before you go on to those harder practice assignments, the Google Slides, I believe.